We've been working with the graphs of trig functions and transforming those. We've been drawing them, picking out the important values that are associated with those graphs, and we've also been practicing matching a trig equation to its graph. So I'm going to run through a couple more examples of these, just so you can see again what we're trying to accomplish. So our goal is to figure out which graph, A, B, C, or D, goes with this equation right here. Y equals 2 plus 3 times the secant of theta over 2 minus pi over 4. Okay, so here's the strategy. And even though I don't have it listed here, you know that our usual plan is to get these values. So the A value in this case is 3. It's not the 2, it's the 3. The 2 is the vertical shift. So this thing is shifted up 2 units. We have a period change. The new period is 2 pi divided by pi over 2, or by 1/2. 2 pi divided by 1/2 is 4 pi. So our new period is 4 pi. This thing got stretched out. And then the phase shift looks like it's going to be crazy because we've got some weird fractions. It's going to be positive 7 pi over 4 divided by 1/2. When you reduce that, flip and multiply and reduce, you get 7 pi over 2. 7 pi over 2 is almost 4 pi, but not quite. Okay, and then don't forget we have these upper boundary lines that we like to draw. And in this case, our upper boundary line is going to be the vertical shift 2 plus the A, which is 3, so that's 5. And the lower boundary line is going to be 2 minus 3, which is negative 1. So we're looking first to use this piece of information to help us locate these graphs. For example, I am tossing out letter D because both the boundary lines are right in here above the x-axis, so there's no negative 1, so I'm getting rid of this one. For letter B, it looks like this boundary line is at 1 and this one is at negative 5. I'm throwing that one out. It's close, but it's the opposite of what we need. This one's at 1, this one's at negative 1. Again, doesn't fit our needs. So I'm left with letter A as my most likely choice. Now we can just double check a few things. For example, we can look at the period to see if it looks like it's going to be 4 pi. So this one crosses over between 0 and pi, and it looks like it's going to have another asymptote somewhere after 4 pi based on this thing. And so I do agree that this period is probably 4 pi. So that's good. We definitely have the vertical shift taken care of, right? Here's that new midline, and there's a distance here and here that's equal. And so that's taken care of. The amplitude is not really the amplitude, but that value with the distance between the upper and the lower boundary lines is 3. It's actually 6. It's 3 each way. And then the phase shift of 7 pi over 2. So the secant function originally starts with the upper branch, the vertex of the upper branch, right on the x-axis. And we've shifted ours over 7 pi over 2, which is between 3 and 4 pi. And sure enough, if we look, the shift, that vertex did move. So all of these things are accounted for. So I'm going to say letter A is the correct choice. Now, if you're in a hurry, and you could just use this information to cross out the 3 and pick A, right? But I'm showing you that all the other information checks out as well. Let me do one more example, and then I'll leave you to try the practice versions that we've posted. So again, we are trying to match this equation, y equals negative 2 plus 2 tangent of theta over 3 minus 2 pi over 3 with one of these graphs, A, B, C, or D. I'm going to take a look at that A value, which is a 2. So remember, that stretches that tangent curve out. The vertical shift is negative 2. That's going to move that midline down 2. We do have a change in period. The period for tangent is pi divided by k, so pi divided by this 1/3 here. That's going to be 3 pi. And then the phase shift is going to be 2 pi over 3 divided by 1/3, so you flip and multiply, and that just comes out to be 2 pi. So we have a phase shift of 2 pi and a period of 3 pi. Well, right away I can see that I'm going to toss out letter A, because if you go between 0 and 3 pi, there are several cycles. 1, 2, 3, 4, 5. There's 5, 6 cycles in there. So the period is not 3 pi, so I'm crossing out letter A. Let's see what else we can do. So I'm also going to throw out letter D because the period is not 3 pi. The period's pi there, so letter D is gone. And basically now we have to decide, is it letter B or is it letter C? And for that, I'm going to take a look at the vertical shift. Remember that for the tangent function, there's that inflection point that usually sits right on the x-axis. And what this vertical shift does is it moves that inflection point down to x equals -2. Now, if you take a look at these two graphs, clearly on letter C, that point is somewhere up here, not down here where it's supposed to be. And so just based on that vertical shift, I'm going to rule out letter C. But what we can also do is make sure that the phase shift also works with our answer before we choose letter B. So remember, originally the tangent function crosses at 0, 0. That inflection point is located right at 0, 0. And this phase shift of 2 pi means we're going to move that thing over 2 pi. And notice that dot that I had drawn earlier is 2 pi over to the right. So keeping that in mind, that we do have the right period, which is somewhere between here and here, which is 3 pi. It's actually probably scooted over a little each way. So we've got the period, which is 3 pi. We've got the phase shift, which is 2 pi, and the vertical shift, which is down 2. So I'm going to choose letter B for this and then move on to the next problems. Again, I went into a lot of detail. If you're using the process of elimination on a multiple choice quiz or test or exercise, as soon as you eliminate 3, if you're short on time, just pick the one that's left and move on. My job as the instructor is to kind of explain why this letter B has to be the choice. And with that, I'll end the video and leave you to practice. If you need me, you know where to find me. Take care.